6th grade, happy Friday. We're moving on with investigation 8 today, and it's going to deal with probability, which we have worked at for a long time. Today we're going to add odds to it, which is one step different and something we normally don't use, and so I think it's a little bit challenging for us. And then we're going to talk about probability with what we call compound events. So the probability of 2 or 3 things happening, and then we'll end it with experimental probability and also what we call theoretical probability. Okay, as we get cruising here, follow along. It says the probability of an event is the ratio of favorable outcomes to the number of possible outcomes. It can be expressed as a fraction, a decimal, or a percent. Normally, probability is a fraction. Normally we use the word chance if we want it in a percent. Like you think about the weather. What's the chance of rain? It's 40%. Okay, so normally I don't say what's the probability of rain? It's 2/5. So chance is usually the percent. Probability is normally a fraction, but your book will ask you for all of them. The range of probability is from 0, which means it can't happen, to 1, which would be 100% it will happen. The complement of event is the opposite. So if the chance of rain is 60, the complement of no rain would be 40 because it has to add up to 100%. So we use that word, hey, what's the opposite of this a lot? And just make sure you understand it always adds up to 100%. You know, if we want to get technical, last time I say, what's the opposite of 60? Negative 60. Okay, so as we continue to speak math, guys, we have the word complement. Now, don't confuse that with complementary. Complementary angles means add up to 90. Complement of an event adds it up to 100. So if 60 is there, 40 is not. Odds are the ratio of favorable to unfavorable. Odds are written with the word to or with that colon right here. So you can see this little colon, guys. Do not write odds as a fraction, but you do have to reduce the number. So if the odds was 6-2, we would say no, the odds is 3-1. I reduced it, but I can't write it as a fraction, guys. Okay, so there's a slight difference here when it comes to odds. Odds can be improper. Probability is not. The times we use odds is mainly just with gambling, guys. What are the odds somebody wins a game? What are the odds I win a lottery ticket? If you see the odds of winning, they always express that as this ratio because it makes it look a little bit better. Okay, one marble is drawn from the bag that has 3 red, 4 white, and 5 blue marbles. That they did the math for you, isn't that nice of them? So they want a total of marbles. What is the probability of picking a white? Hang on one second, forgot my pen. Okay, here we go. So the odds of picking a white. There are 4 white. There are a total of 12. Okay, so I got 4 12s. Now they have an equal sign. Why? Because this isn't reduced. So I divide by 4, I get 1. I divide by 4, I get 3. That equals 1/3. Then they ask me, what is the probability of not picking a white? So how many of them are not white? Well, 5, 3 is 8. Or you could have done 12 minus 4 is 8. How many are there total? 12. Once again, I need to reduce by dividing by 4. Divide by 4 and I get 2/3. These are complements, guys, of white to not white. They would total 1 whole. Now the question is, what are the odds of picking white? Well, how many of them are white? 4 of them are white. How many of them are not white? 8 of them are not white. The odds are 4-8. Now I'm going to write the answer again, guys, because I want to reduce it down. So divide by 4 is 1-2. Okay, if I ask you what's the probability of getting a white, you would say 1/3. What are the odds of getting a white? 1-2. And because we are so used to probability, guys, we think this is a better chance, don't we? Because I have a 1-2 and I just read that as, I have a half chance of getting white. It's not, guys. For every 1 time you get it right, 2 times you'll get it wrong. For every 1 time you get a white, 2 times you won't. Do you understand why we use this on lottery tickets? Because I look on the back side of my lottery ticket and I say the chances of winning $1 is 1-2. And I think, well, if I buy 2 of them, I'll win once. That's not true, guys. If the odds are 1-2, the probability of winning is 1 out of every 3. So, lesson number 1. You might want to use it for extra credit. We write in odds because it allows our lottery system to make more money. People think they have good chances of winning, guys, because they don't understand math well enough. Okay? So if it costs me $1 to buy a lottery ticket, and it's going to really, I'm only going to win 1 out of every 3 times that dollar back. So if I bought 3 lottery tickets, I would win once, just if I'm following the math. That means 2 times I lose money. That's not good work. Okay, lottery system is rigged to make money. 4 says, what is the probability of picking a red? All right, so I'm to red. I started with a fraction, 3/12. I reduced it by dividing by 3 and got 1/4. I have 1/4 memorized to 0.25. Then it says, what's the probability of not picking red? Well, guys, what's the opposite of 0.25? It would be 3/4 or 0.75, because together it has to add up to 1 whole. Now, back to the practice. What are the odds of picking a red? How many reds are there? 3. How many not reds are there? 9. That reduces to divide by 3 is 1, divide by 3 is 3. The odds are 1 to 3. So the way I check to see if I'm doing this right, guys, is I'm used to probability. So what was the probability? 1/4. What are the odds? I have to add those together, guys, and that will give me my denominator. So that's your check mechanism to it. What are the odds of picking a blue? How many blues are there? 5. How many not blues are there? 4 plus 3 is 7. And in this case, that's already reduced. The meteorologist says that the chance of rain is 20%. According to the forecast, what's the chance that it'll not rain? Well, if you want to see the math, guys, percent always adds up to 100. If there's a 20% chance it's not going to rain, that means there's an 80% chance it will not rain. So I think I said that wrong. If there's a 20% chance it will rain, there's an 80% chance it won't rain. Okay, this we've done, this we've done. This in my mind is a new thing, and because it's new, it's confusing because it kind of goes with probability, but my brain is so used to probability that the new odds thing can become a distraction. So be careful that we read questions carefully when it comes to odds. Backside, according to the forecast, what are the odds that it's going to rain? Well, guys, we wrote the answer for rain at 20. We wrote the at not rain at 80. If I chop a 0, I'm down to 2/8. If I divide, I have 1 to 4. So we read that 1 to 4. We don't say 1:4. This is the word 2, 1 to 4. A compound event is 2 or more simple events happen. To find the probability of a compound event, you multiply the probabilities of each simple event. So a coin is tossed, the spinner is spun. What is the probability of getting heads and a 4? So they said the probability of heads and a 4 looks like this. So if you work in IXLs with probability, guys, they are going to put in parentheses what they want. You want a heads and a 4. P stands for probability. Is the probability of heads times the probability of 4? What's the probability of getting a heads? Well, heads or tails? 1 out of the choice of 2. How many number 4s are there? 1 out of 4 possibilities. So a half a chance to get heads, a fourth of a chance to get the number 4, and I multiply them together. 1 times 1 is 1, 2 times 4 is 8. Now they're going to show you what we've been doing in the past. What's the sample space? Well, I can go heads 1, heads 2, heads 3, heads 4, tails 1, tails 2, tails 3, tails 4. Find the probability of heads and 2 by multiplying the probability of heads and the probability of 2. Guys, that's this math right here. The probability of heads is still 1/2. The probability of 2, there's still 1 out of the 4. So my probability would be 1/8. They said check your answer by inspecting your sample space. How many heads 2s do I have? 1. How many are there total? 8. 12. What are the odds of heads 2? How many heads 2s are there? 1. How many not heads 2 are there? 1, 2, 3, 4, 5, 6, 7. Okay, what was the faster way? Remember, it's got to equal 8. So 8 minus 1 is 7. 13. What's the probability of heads and not 2? Well, the probability of getting a heads, guys, is still 1/2. The probability of not a 2 is 1, 2, 3. There's actually 3 out of the 4 are not 2s. I multiply them together, that gives me 3/8. Okay, so heads and not a 2, heads and not a 2, heads and not a 2. You would multiply the probability of 1/2 by the probability of 3/4. I don't know why the 2's there. If a coin is flipped 3 times, what is the probability of getting a heads all 3 times? Well, guys, the probability of getting a head the first time is 1 out of 2. The probability of getting a head the next time is 1 out of 2. The probability of getting a head the next time is still 1 out of 2. What I did in the first time has absolutely nothing to do the second time, which has absolutely nothing to do the third time. So now I just multiply the tops. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the chance of going heads 3 times in a row is 1/8. If a number cube is rolled twice, what is the probability of getting a 6 on both of them? Well, there's 1 6 out of the 6 numbers. There's 1 6 out of the other 6 numbers. So 1 times 1 is 1, 6 times 6 is 36. The chance of you rolling a pair of 6s is going to happen 1 out of every 36 times you do it. That's what we call theoretical math. That's what it should happen. Now, guys, if you roll dice, might you get double 6s more than 1 out of every 36 times? Absolutely. That's what we call experimental probability, which is what we're going to talk about here at the end. Page 3. If a number cube is rolled and a coin is tossed, what is the probability of getting heads and a 6? Well, the probability of getting the heads, we've done all the time now, is 1/2. The probability of getting a 6 on a number cube is 1 6 because there's 6 numbers and one of them is that, and I'm supposed to multiply today. So I should get 1/12. Now they said, prove it. Well, heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. Restart, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. Okay, guys, you've been doing sample space. As we get to higher level math, we don't want to do sample space. Sometimes it's still needed for complicated ones, but you know, if we did the sample space of rolling 2 dice, now I have to write this 36 times because there's 36 different things I could get. That starts to takes too long. I want to know the math behind it. Okay, theoretical probability is when we calculate the ratio between the favorable and possible outcomes. This is theoretical probability. Experimental probability is when we actually do the experiment many times. We count and compare the favorable outcomes to the number of trials. So you actually do it. This is what's supposed to happen. This is what reality might be. Okay, so if I flip a coin, guys, and I get heads the first time, theoretical would say the second time you should get a tails because it should be going every other time. Head, tail, head, tail. And some of you know you can flip a coin and you can go heads, 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 tails, tails, heads, tails, tails. It never just works out perfect. Head, tail, head, tail, head, tail, head, tail. Okay, consider the spinner shown here. The spinner was spun 360 times. The results were recorded in this table. So we spun it, we got an A, we got a B, and we got a C. When we spun it, we got an A 60 times, we got a B 90 times, and we got a C 210 times out of our 360. Now, guys, if you're doing experimental probability, they said many times. This is what they're talking about. They're talking about hundreds of times. So if I flipped a coin 10 times, it probably won't be 5 heads, 5 tails. It might be 6, 4. It might be 7, 3. If I flipped a coin 1,000 times, the more times I do it, the closer it'll get to the 1/2 ratio. So if I did it 1,000 times, not that it's going to be perfect 500, 500, but it might be as literally like 490 to 510. So in other words, it's going to get pretty close the more times I do it. What is the experimental probability of spinning an A? Well, they said an A was 60. So I got 60 over 360. I chop this down off of 0. I divided by 6. 6 divided by 6 is 1. 36 divided by 6 is 1/6. What's the experimental probability of spinning a bee? Well, that was 90, guys. Chop off a 0, divide by 9 is 1, divide by 9 is 4. Experimental probability for C, 210. Chop a 0, divide by 3 is 7, divide by 3 is 12. Based on the results of the experiment, what fraction of the spinner's face is sector C? Well, it looks like it's 7/12. About what percent of the spinner's face is sector B? Well, that was nice. They gave me the 1/4 one, guys. That's the one that I have memorized, 25%. Okay. Boom, we're not doing the experimental probability. Okay, guys, that's probability. We'll continue to work them, obviously, for our 40 lessons here in our book. Let's do a quick review. The quick review is to figure out the theoretical probability. You simply multiply your outcomes together. Second review today that is important is odds. Odds are number that I want compared to the number I don't want. It is written with a colon, never as a fraction, always reduced. I think this is the hardest one for us. I think theoretical probability makes sense because we've been doing it enough times. Okay, don't play the lottery because chances of winning aren't good. All right, guys, have a blessed day.